heute Abend. In diesem zweiten Teil werden wir zunächst einmal den zweiten Vortragsteil von Professor Kozyrev über die inhaltlichen Themen des Werkes seines Vaters hören. Dort steht der spannende Begriff der Zeit im Mittelpunkt. Ja, die Zeit ist so einer der wichtigsten Aspekte des menschlichen Lebens und doch wohl das am wenigsten Fassbare. Und diese faszinierende Einsicht von Nicolai Kozyrev, dass die Zeit mehr ist als nur ein Ordnungsparameter unserer Welt, eine Kategorie, in der man sie wahrnimmt, sondern vielmehr eine aktive Kraft sein könnte. Das ist das, was mich gerade so an dem Modell Kozyrevs fasziniert. Darüber werden wir jetzt aber gleich ausführlich mehr hören, was dann eine gute Basis sein wird für den zweiten Vortrag, den unser IACR-Team geben wird. Dort wäre das Institute of Applied Consciousness Research, wo wir über unsere eigenen aktuellen Forschung und Forschungsergebnisse zu diesen Themen berichten werden. Und im dritten Teil werde ich mich dann um eine philosophisch, psychologisch, wissenschaftlich, spirituelle Einordnung dieser Themen bemühen und bekomme dort, bin total glücklich, ganz tatkräftige Unterstützung. Das wird aber jetzt noch nicht verraten. Also für den ersten Teil freue ich mich jetzt wieder ganz besonders, Professor Kozyrev zu begrüßen und zu bitten, uns den zweiten Teil seines Vortrags zu halten. Bitte schön.
Dear friends, I would like to start this lecture, which is this part of my presentation, which is much more dense and voluminous than the first one, with the reference to the main source of information about Kozyrev. Here you see a picture of the home page of a website. This is the picture by Leonardo da Vinci, which is called The Philosopher Studying, or The Philosopher Thinking About Time. Understand Kronos, time, MCU, it is Moscow State University. So this site is hosted by this main higher educational institution of Russia. And here you see a photograph of a heroic man, Alexander Levich, who is for more than 20 years leads the seminar on the exploration of time. He is the head of the Institute for Time-Nature Exploration and the host of this in English, but mostly they are in Russian. Unfortunately, English version is very poor, so if somebody would like to help you. Now it is also in a situation of restoration. That's why there are some difficulties, but you will find many, many interesting works, hundreds of works, and almost 100 of authors who present their views on time. I am a leader of the Laboratory for Collection and Analysis of Empirical Data on the Natural References of Time, and I will return in my presentation to the materials which are presented on this department of the website. So among the things that exist and that are named by human beings, one can hardly find anything more mysterious than time. What is it? A form of a priori reasoning, a measure for the correlation of things, or a thing in itself? Dependent upon the answer is the very feasibility of the study of time, as well as the choice of corresponding methods, tools, and language. If time is a condition of our thinking, as Kant was inclined to believe, the idea of empirical study of time becomes absurd. But in the history of human thought, we find other approaches that do not exclude time from the possible objects of study. Isaac Newton used to talk about absolute, true, and mathematical time, which of itself and from its own nature flows equably, without relation, to anything external. This definition presupposes the existence of time dependent neither on us nor on the physical processes through which it becomes detectable and measurable. This kind of substantial understanding of time makes possible its study on the same premises as we study other natural phenomena. Following this line, Hans Reichenbach, the leader of the Berlin group of logic positivists, claimed in the middle of last century that the resolution of the problem of time is to be found not in the sphere of metaphysics, but among the lines of physical studies. Physics, according to him, is much closer connected with the nature of time than any other branch of science. I give a quotation from his book. Here you see this short version. The book is The Direction of Time. So if time is objective, the physicist must prove this fact. If the becoming exists, the physicist must scrutinize it. But if time is only subjective and existence is timeless, then physicists must have an opportunity to ignore it in his interpretation of reality and to describe the world without references to time. Yeah, of course, it is a translation from German to Russian and from Russian to German. So if you go to Reichenbach, it will sounds a little bit different. As Kozyrev underlies in his causal mechanics, since Newton, we used to imagine time as possessing only one passive and scalar property. This property allows us to estimate duration of events or the size of time episodes measured by clocks. But this property doesn't help us to fix differences between cause and effect. Since the difference between cause and effects do exist, we should conclude that time possesses one more special property. And that active property of time, according to Kozyrev, should be carefully studied by physical experiments. So the term physical time may be applied to a substance possessing that kind of active property that allows us to distinguish between cause and effect in the process of this world. In order to clarify this distinction, one spatial analogy may be helpful. It is borrowed from Rudolf Carnap's book, Philosophical Foundations of Physics. This is the distinction between physical and mathematical geometry. While the former is empirical theory, the latter is purely logical construction, as Carnap explains. Developing further this notion, he refers to a rather legendary story of how great German mathematician and astronomer Carl Friedrich Gauss decided to prove empirically which one of the two mathematical geometries corresponds to the real world. For that aim, Gauss triangulated tops of the mountains and planned to triangulate stars. Carnap adds that if Gauss actually didn't perform this test, the legend itself is a milestone in the history of scientific methodology, for Gauss was the first to put an avant-garde question of what shall we find if we try to study geometry of special structure by empirical means. According to the legend, Gauss understood that he will be mocked by his colleagues and decided not to publish his results. And only in the 20th century, Carnap resumes, mathematicians started to realize that the multitude of mathematical geometries raised the real empirical problem of finding the geometry that fits our real world. And that is the key, in my view, to evaluate the main contribution of Kozyrev to the development of science. He was the first who designed the examination of physical time as the real substantial flaw interacting with our material world. In this sense, it would be fair to regard him as the founder of physics of time. The development of the idea of physically active time constituted the overall aim of Kozyrev's scientific activity and remained in the distal focus of his research, whatever were the nearby tasks and particular methods. Whether he was doing planet or star observation, research of the Earth or lunar volcanic activity, experiments in the lab or geographical expeditions. Soon after making his principal claim about the participation of time in physical interactions, Kozyrev understood that his idea entails essential correction of the system of physics that had been developed without taking into account cause and effect relations. Thus, the theory became a project of the revision of basics of classical science. The history of the project realization can be divided into 4 stages. 30s and 40s. Astrophysical disproof of the theory of thermonuclear nature of stellar energy. As a result of this research, the dissertation was defended in 1947, presenting an alternative theory of the internal constitution of stars. Second period. In the early 50s, in the course of the research for the outside sources of stellar energy, Kozyrev turns from astronomy to experimental physics. He works out the axiomatic frame of causal mechanics and starts laboratory mechanical experiments aimed to determine its main constant. He called this constant the course of time. The main product of this stage is causal or asymmetric mechanics in linear approximation. 1958. The third period. In 60s, Kozyrev turns again to the thermodynamic problems. Experiments are redirected to study the variable property of time called density of time. The search for regularities in the interaction of time and matter are in the focus of the research. Results of this stage remained mostly unpublished in his lifetime. And fourth, in the middle 70s, we see a reversal movement from experimental laboratory work to experimental astronomy. Communication and interconnection of distant objects by means of time are studied on this stage. Several articles on that topic covered the period between 1976 and 1985. One of them is presented on the slide. Results of the first stage are now available in English after their publication in Progress in Physics in 2005. In order to explain why the 60-year-old article appears in the journal with such an unsuitable title, Progress in Physics, the editor supplied it with the following comment. Although this research was started in the 40s, it remains relevant today because the basis here is observational data on stars of regular classes. This data has not changed substantially during the intervening decades. Indeed, Kozyrev's conclusions were based on the well-known, observable, and calculated data on basic stellar parameters, such as mass, radius, luminosity, and spectral characteristic, and on juxtaposition of this data with the assumed age of stars and resources of their energy. To put it very simply, the author managed to arrange data in an unusual but suitable way so that the correlations between the parameters reveal a very important regularity. Stars emit the amount of energy they would emit if they were merely cooling down. The situation became quite improbable, for it meant that all stars, so diverse in their configuration, distance, and force, have exhausted their energy just at the moment the mankind appeared and started to study them. More reasonable would be to assume that they never had internal sources of energy. This assumption became a launching pad for the search of the sources of stellar energy outside stars. And here the cosmic intuition of the eternal youth of the universe finds its empirical proof. If stellar observational data are analyzed without prejudice, the luminosity of stars turns to be the desirable key to the secret of vitality of our world. This very analysis occupied Kozyrev in Dmitrovsk prison in 1938 when he desperately needed the book. Returning to the matter of its miraculous appearance, we know at least that the data he received were accurate. And so he was able to complete his analysis that became the main theoretical basis for all future work. It may seem paradoxical that the revelation about everlasting life of the universe was received there, in the spot of space-time, where concentration of evil was immense. But this factual detail closed the story in truly religious and more definitely in Christian terms. Besides the problem with stellar lifetime, there was another argument against thermonuclear reaction that followed from Kozyrev's analysis. Dadaev expresses it the following way. Comparison of the theoretically derived dependencies with the observations statistically leads to the conclusion that the temperature at the centers of stars of the same type as our sun doesn't exceed 6 million degrees, whereas the temperature necessary for reactions of nuclear synthesis is over 20 million degrees. Moreover, in the thermal balance of the star, the defining factor is the energy emitted. But the estimated energy generation of thermonuclear reactions, if they operate in a star, far exceeds the observed emitted energy. Thus, reactions of nuclear synthesis are impossible because of insufficient heat in the stellar core. Dadaev's argument was developed by one of the Kozyrev disciples, recently deceased, a physicist Pavel Znikin, who made a marvelous video about Kozyrev called The Kozyrev Star. And you can find this video also on the website of the Institute. There he argued that Kozyrev fairly brought attention to an obvious contradiction neglected by the majority of astrophysicists. According to the minimal temperature required by nuclear reaction, each square centimeter of sun should emit 6,000 watt. Knowing the mass of sun, we can also calculate energy rate, which appears to be absolutely incompatible with the first figure. Namely, you see this figure here on the bottom, 10,000 watt per kilo. The two numbers may be matched only if we suppose the existence of a cool or cold layer between the burning core of the sun and the glowing surface, which hypothesis also sounds very strange. I would like to witness that my father never doubted this rather shocking conclusion. He didn't refuse the possibility of thermonuclear reactions later that can happen inside star. But for example, for our sun, he estimated the input of this type of energy into radiation as hardly more than 10%. In his article written in the 1970s, that is about 35 years after the analysis had been completed, his verdict sounds even firmer. The standard calculation of stars, of the chemical composition of stars, lead to a wrong conclusion, and hence they present a kind of formal operation used to adjust equations of reactions to the data observed. That's why the stellar models based on the hypothesis of thermonuclear reactions, conclusions about the evolution of stars, and all huge literature presenting implications of this idea are not in accordance with reality. Accurate analysis of observational data leads to a conclusion that stars are not thermonuclear furnaces, but rather machines producing energy of another kind. The rate of production is regulated by the rate of emission, and the source of this energy lies outside stars. Today, when again about 35 years passed once more, the raise of interest of astronomers in Kozyrev's view is obviously stimulated by new data about cosmic radiation from distant sources. This data, obtained in particular at the Pierre Roger Cosmic Ray Observatory in Argentina, also do not meet prognosis made on the basis of classical doctrine and calls for the change of scientific paradigm. The second stage constitutes the central part of the project. Causal mechanics was foreseen by its author as a theoretical basement of the new physics, divergent from the existing systems of physics in the recognition of the objective difference between past and future, and in consideration of the cause-effect transition as a physical process produced by interaction of time and matter. The hypothesis of time being the wanted external source of stellar energy breached the second stage with the first one, during which the necessity of such a source was proved. So the results of the first stage naturally found their place in causal mechanics as its astrophysical introduction. But why time? The answer to this question is to be found not in the realm of astrophysics, but among the most common assumptions that, in Kozyrev's words, come from the experiences of natural sciences as such, and from the experiences of life. This is the quotation from one of his books. Comes from the experiences of natural sciences as such, and from the experiences of life. This is the most intriguing, hidden, and in my view, the most metaphysical link in the whole sequence of Kozyrev's reasoning, leading to some tacit assumptions and insight lying behind his reasoning. And I am more and more sure that when he spoke about experiences of life, he might mean not quite ordinary experiences, but rather insights obtained in extreme situations, or peak situation, as psychologists use this expression. For him personally, that obviously might be the experience of a prisoner, confined in space and time, in such a painful manner that he could feel the rigidity of time almost physically, and it could stimulate specific sensation and further reflections on the essence of time. Time appeared in his existential experience as a force. Leibniz criticized Cartesian idea of passive matter and insisted that matter shows an active property of resistance to our will. In Kozyrev's contemplation, this active element of nature resisting our will was associated with the flow of time. In a wide context of European philosophy, the closest analogy of this vision I find in George Berkeley. And this is an interesting coincidence in my view, because Berkeley represents the same British empiricism, another representative of which was Newton, so highly valued by Kozyrev. We should not neglect the fact that Kozyrev himself was a consistent empiricist. In one of his most frequently quoted sentences, describing their delight after the first success with the balance, success in detecting the flow of time, he writes, "A miraculous perspective of influencing physical tools by means of time opened before my eyes. Many volumes of philosophical contemplations on the nature of time may be removed from the bookshelf, because even the strongest imagination can't be compared with the experimental investigation of real world." I think sometimes that this devotion to empiricism was fatal for Kozyrev's career as a philosopher. It absorbed a huge amount of time, and it made him to use scientific language comprehensible for a tiny minority of readers. If he preferred philosophical contemplations, his cosmology probably became much better known and received much stronger attention. The distinction between imagination and reality mentioned in the quotation occupied heavily Berkeley's mind. In the history of science, this outstanding person for a long time was received with a smile, and it was not a good tone to take his ideas seriously. It was he who denied the concept of matter, and who came with the most eccentric idea of non-existence of material world without observer. It provided a good material for students' competition in wit and for jokes, as it is shown particularly on the slide. Only recently, in the course of philosophical reflection on quantum physics, it became clear that Berkeley's ontology is more relevant to the contemporary understanding of physical reality than traditional scientific beliefs. Besides that, historians of philosophy found that Kant was much stronger influenced by Berkeley than one could think, though he didn't want to expose this influence. A short fragment from Berkeley's treatise concerning the principles of human knowledge disclosed some interesting points related to Kozyrev's idea of active time. I will bring it because, in my view, it covers somehow, brings some light to this most dark spot in the history of all Kozyrev's evolutions of Kozyrev ideas. So this is quotation. "We perceive a continual succession of ideas. Some are anew excited, others are changed or totally disappear. There is therefore some cause of these ideas whereon they depend, and which produces and changes them. I find I can excite ideas in my mind at pleasure, and vary and shift the scene as often as I think. It is no more than my willing, and straightway this or that idea arises in my fancy. But whatever power I may have over my own thoughts, I find the ideas actually perceived by sense have not a like dependence on my will. When in broad daylight I open my eyes, it is not in my power to choose whether I shall see or no, or to determine what particular objects shall present themselves in my view. And so likewise, as to the hearing and other senses, the ideas imprinted in them are not creatures of my will. There is therefore some other will or spirit that produces them. The ideas of senses are more strong, lively, and distant than those of my imagination. They have likewise a steadiness, order, and coherence, and are not excited at random as those which are the effects of human wills, but in regular train or series. And these we learn by experience, which teaches us that such and such ideas are attended with such and such other ideas in the ordinary course of things. So this Berkeley's course of things, responsible for the rigid cause and effect relation that makes the world of real things so different from the world of imagination, and that have a source in some other will or spirit, corresponds closely to what Kozyrev called the course of time. Kozyrev's active time is the agent bringing order into this world, turning it into cosmos, and resisting the dissolving power of chaos. I would like in this regard bring one more philosophical observation presented in the Centenary Time and Stars by a Greek author, Dimitris Leovididis. It is a common belief that causes usually occur earlier than their effects. Doesn't this distinction between causes and effects give time a sense of direction? A question mark. As serious objections come forth. Unless causal theorists can distinguish between the events that considered as causes and the events that consider as effects without appealing to the earlier later distinction, then their argument runs circular. According to Hume, the equation cause equal early event, effect equal late event are merely linguistic conventions. As Danton eloquently puts it, to avoid the charge of triviality, causal theorists must provide a substantivalist account of causal priority. It means how causes differ from the effects that doesn't appeal to temporal priority. And he concludes saying the only thing that is clear and relatively uncontroversial is that finding an objective and non-temporal difference between cause and effect is a far harder task than one might have imagined. And so a good many philosophers have concluded that there is no such difference. There, Leovididis continue, comes Kozyrev's ingenuity. Having recognized all these difficulties, he builds causality not within time, but from time. That is, time itself has the capacity to distinguish between causes and effects. It is time, through its direction, that creates causality, not the other way around. This seems to me to be the central postulate from a philosophical point of view of his whole theory, concludes Leovididis. And yes, I agree with him, and it comes as the first and the basic postulate of causal mechanics. You see this postulate on the screen. Type possesses a specific property, distinguishing causes from effects, which may be called course of time. This property determines the difference between past and future. This very property makes time not only mathematical, but physical reality. And so the difference between the past and the future becomes also not conventional, but absolute, implying energetic effects in case of their reversion. And then two other postulates, you see them here, they deny the possibility of non-zero space, difference between the elementary, in elementary processes, the difference between cause and effects, both in space and in time. So they imply impossibility of coexistence of causes and their effects at the same point of time and space. That's most important for the future causal mechanics. Time and space are treated here equally as two interconnected conditions of physical processes. The relation finds later its formalization in what Kozyrev called the main theorem of causal mechanics. It sounds like this: a world with the opposite flow of time is equivalent to our real world reflected in the mirror. A symmetrical property of time is conjugated with the inequality of the real world and the mirror image of the real world. As Kozyrev regularly emphasized, his causal mechanics is not in contradiction with the Newtonian mechanics, but includes the latter as its extreme case, corresponding to the maximum strictness of cause and effects links. Causal mechanics is confronted on one side by Newtonian mechanics, which allow simultaneity, but not allow superposition of bodies. So the course of time becomes a positively infinitive value, as you see on the left column. And on the other side, it is limited by wave mechanics of elementary particles, where superposition is allowed, but irreversibility takes place, and correspondingly the course of time turns to zero. Causal mechanics is a system in which the ratio of the smallest possible distance between cause and effect, between interacting objects, is a finite quantity. And later it was estimated as 2,200 kilometers per second. One of Kozyrev's living disciples and interpreters, Lavrenti Shikhabalov, dwell on the relation between causal mechanics and the two mentioned classical systems. The existence of the additional time forces that makes the Kozyrev world distinct from the Newtonian world may be treated from his point of view as a result of a deviation of classical forces acting according to the following principle. The interaction forces between each two internal points of the system have the same line of action. Well, we know it from school, yeah? These additional forces do not change the impulse of the cause and effect link, but only its angular moment from the point of view of Shikhabalov. So they cause the rotation of the link. In order to reconcile two mechanics, one need only to refuse the universality of the mentioned principle of one-line interaction. Shikhabalov points to the fact that some traditional branches of mechanics, such as mechanics of continua, are formalized without this principle, so its negation by causal mechanics is justifiable and not unique. Regarding the relation between causal and quantum mechanics, it is worth to remind the remarkable Planck equation. So we are talking about the other side, how it corresponds to the Newtonian and how it corresponds to the quantum mechanics. We should remind that remarkable Planck equation for the first time put a sign of equality between the energy and the temporal characteristic. Causal mechanics deepen the physical meaning of this equality. One of its general conclusions consists of the claim that time possesses energy, and this very conclusion, more than any other in Kozyrev's theory, means the real switch of Gestalt in our vision of the world. The idea of never-ending movement lying at the core of classical thermodynamics is based on the possibility of superposition of causes and effects, first proposed by Robert Meyer. In order to formalize this possibility, the vector force used by Newton had to be substituted by a scalar variable, energy. Meyer chose this energy, or living force, as it was called and actively supported by Leibniz. Quite contrary to that, causal mechanics forbids superposition. So, because cause and effect cannot be exist in one place and one time. So the ceaselessness of movement, the eternity of movement, is ensured not due to, but rather despite superposition. It is embedded in the dynamic nature of time. The laws ensuring the quantitative predictability of motion and the strictness of cause and effect relations are conjugated here not with the principle of conservation of something, be it conservation of impulse, of matter, of energy, or whatever else, but with the structure of space-time relations, namely with a rigid relation of spatial and temporal intervals between cause and effect in the elementary mechanical process. It is not accidental that this structure is defined in the Kozyrev world not with the scalar, but with the pseudo-scalar characteristic, equidimensional to speed. The world of causal mechanics is flowing, or lotic world, and this is what makes it utterly different from the world reservoir, which we are accustomed to. As Cartesian kinematics acknowledges only one characteristic of matter, its spatial extension, so the causal mechanics requires only one ontological premise to be added to physics, the intercession of the flow of time in all kinds of movement. Cartesian kinematics considers movement as transposition in space. The causal mechanics considers movement as transposition in time and by means of time. The source of the dynamism of the universe is embedded not in the absolute properties of space, as Aristotle and partly Descartes believed, and not in the properties of matter, as Leibniz believed, but in time that is inevitably involved in every interaction. The most important outcome of causal mechanics envisioned by its author is the possibility to attain the flow of time in order to amplify the processes that run against the increase of entropy, that is, the processes of life. And it leads us to the third stage of Kozyrev's project. In a sense, the transition to the third stage manifested the return to the problems of thermodynamics that had been at the focus of the study at the beginning, but had to give place to mechanics. Yet the actual reason for the reorientation of experiments was connected with the serious impediments that the researcher faced when trying to discover the constant of the course of time. It really wasn't constant. These difficulties required the introduction of one more characteristic of time, signifying its variable property. And this was a really dramatic moment in the history of the project, since the introduction was evidently in contradiction with the desire to achieve as simple and strict formalization as possible for the theory. The first hint about new orientation sounded in 1962. The intensity of the effects observed was reported to change considerably because of some external factors located outside the lab, and therefore a variable physical characteristic of time was demanded. It was called intensity, or later density of time. The first cycle of experiments aimed to discover and estimate the mechanical additional forces predicted by the theory was successful. The start of the second cycle of experiment manifested the break of these attempts in order to focus on the impediments or predicaments themselves. Figuratively speaking, the flow of time wasn't anymore the object of study. Instead, it was the content of this flow and the neighborhood and the laws governing transposition and transformation of the content by the carrier that was in the focus of the study. What does this content of the time flow mean in physical sense? To answer this question, we should recollect one of the basic notions of theory, that is the negentropy essence of time, or substance, negentropy substance of time flow. Time compensates the increase of the entropy in the universe and prevents its arrival to the equilibrium position. Since entropy is a measure of organization, heterogeneity of time flow may be caused by bunches and depressions of organization, or of the energetic component of structure in general. Bits of information carried in time also may be a factor of such heterogeneity. This cycle of experiments was performed using other detectors. Particularly the most successful and well-known Kozyrev invention, the asymmetric torsion balance. One of the versions you can see here presented by our colleagues with the Ludwig Thorsten. The main outcome was the discovery of the following rule. Density of time is higher wherever a process takes place that increases entropy in the surroundings of the experiment. This rule supported the idea that time carries negentropy, but moreover it proved matter to be able of accumulating time and giving it back in a regular manner. The existence of such a feedback between time and matter had not been predicted by causal mechanics, and so appeared as the most intriguing finding of the third stage. The effect of time condensation caused by the loss of structure or the loss of organization in different systems becomes the priority of study in 70s until the death of Nicolai Kozyrev in 1983. In the course of experiments at this stage, the torsion balance was found to be affected not only by thermodynamically irreversible processes, such as dissolution of salts, burning, or deformation, but even by the work of human mind, as Kozyrev puts in one of his articles. From theoretical perspective, the observable interactions gave grounds to apply causal mechanics conceptual framework to the resolution of the problems of non-locality, and also to put on scientific grounds the examination of the phenomena which are traditionally defined as paranormal. His research evidently was near to face the problem of demarcation between the material and non-material. Now I will try to sum up the main practical results of this stage, the third stage of his project, and their implications for natural sciences, including medicine. First, notion of energy to information and information to energy transitions. In his late experiments, Kozyrev discovered the phenomenon of weight loss in the solid bodies subjected to irreversible deformations. This phenomenon was interpreted as the release of mechanical energy caused by their restructuring. Notably, both the loss of weight and its recovery were not instant events, but rather gradual processes, taking some 15-20 minutes. And this pointed to the possible affinity between processes of informational exchange and heat exchange. Imagine a canvas put on scales together with all painting stuff. When the canvas will be weighed again together with the rest of the stuff and with the picture painted on it, the overall weight will be different. The import of organization into a material body should increase its weight, and the destruction of its inner organization should make the body lighter. In terms of cosmogony, the finding of the equivalence of organization and energy means the possibility of the formation of matter from idea. It seems that the intrusion of this notion into physical knowledge may create a better theoretical framework for the exploration and explanation of many widely known facts about influences that ideas, thoughts, and moods, forms of organization, or of the environment and other related factors may have upon the physical health. Today, the role of auto-hypnosis in explanation of these effects seems to be overestimated. Secondly, notion of negentropean interchange between physical bodies by means of time. Once in the past, this idea led Kozyrev to the discovery of lunar volcanism. It was not accidental that he found this. He was at the good moment in the place where the eruption was there. He monitored moon. He was sure that he should find some, will meet these moments. And it was for him very difficult because people at the observatory mocked him for this and said, what are you looking at the lunar? It is completely well known. You will find nothing new. One in the past, this lunar idea of the lunar volcanism came out of this second consequence of the causal mechanics. Active properties of time, according to Kozyrev, should enhance additional energetic exchange between bodies involved in mutual rotation, such as binary stars or planet pairs like Earth and Moon. As a result, these joint objects should resemble each other more than it may be expected when basing on the known physical laws. The scrutiny of this exchange may give us a key to understand many poorly explained phenomena, like telepathy, sympathetic magical coercion, etc., and to develop defensive strategies and means. To use my father's joke, the theory helps us to explain why dogs look sometimes so much like their owners. To be more serious, there is a growing number of data providing the existence of unexplainable influence of planets and sun on physical processes on the Earth. These data encourage the review of skeptical attitude toward astrology, usual for scientific establishment. Just to mention one example, the famous Nobel Prize winner in economics, Maurice Allais, who was also a skillful experimenter, fond of astronomer, registered a remarkable disturbance in the behavior of a mechanical pendulum during the solar eclipse of 1954. We present these data, these articles on our website. Notion of the existence of natural generators of organization or devices for the absorption of energy from time. That is the third consequence. One of such mechanisms is rotation. And Kozyrev regarded massive rotating bodies, first of all stars, of course, as machines producing energy from time. However, he believed that asymmetry so widely presented in the plants and animals, in their morphology, in their chemical asymmetry of protoplasm, discovered by Louis Pasteur, they are also devices for the similar function. Regarding these biological facts, Kozyrev wrote, this stubborn heredity, asymmetry of organism can't be accidental. Evidently, it emerges as a consequence of natural laws, where asymmetry is present because of direction of time. The asymmetry of organisms may be not only a passive implication of these laws, but a special device for the amplification of the living processes by means of the course of time. Current development of this idea in the field of astrophysics, one can find, for instance, in Shikhobalov's attempt to resolve the problem of DNA replication on the basis of causal mechanics. Just to remind, what is the problem? It derives from the mechanical impossibility to split a spiral in two without rotation. It means that in order to replicate, DNA should be always rotate. And there is no such an energy from thermodynamical point of view that give a possibility for everlasting rotating of DNA within the cell. Another field of implication is culture. One of the articulated guesses of my father was, which I personally remember, was the idea that spinning and reeling, so important and widespread in the folk art and in religious rituals of different peoples, may also be considered as a mechanism for intensification of interaction with time. The feasibility of artificial means for absorption of energy and organization from time is the next notion. It directly follows from the previous one. Kozyrev did first practical steps on this way through experimental study of time forces and laws determining their reflection, shielding, decreasing with distance, and penetration ability for different materials. Kozyrev mirrors designed by Vladimir Koznachev, are based on these studies. This perspective of the development of Kozyrev's theory is fascinating and frightening. The idea to draw energy from time supposes that we can hasten the moment when time will run out, more so as we don't know how much of it we have ahead. This theme is a matter of my father's, was a matter of his concern, but he believed that the source of energy disclosed by his theory can't be used destructively or unguardedly. The first reason for the impossibility is the low density of this energy. It can attain levels comparable with nuclear energy only in huge objects like stars. Forces attainable within the earthly scale would hardly produce more than homeopathic effects. They would be able to harmonize relationships of an organism with its environment, but unable to work against natural course of events. This energy is able to support an organism in the crucial moment, but hardly will allow it to make provisions for future, because its carrier is time, and one can't stop time. At this point, Kozyrev's views anticipated synergetic ideas of non-equilibrium state of nature and of the decisive role of weak influences. Regarding distractions, it may be also assumed that physical action of time is charged with the irreversibility opposite to one we have in thermodynamics. Let's say time is plugged in to our universe in order to import organization and not to export it. In order to use the time force for the production of energy, one needs to change the poles, that is to redirect the river of time. Fifth, in fact, the direction of time forces in causal mechanics depends on relationship positions of causes and effects. So the fifth point is that causal mechanics makes possible to distinguish between causes and effects when necessary, and when the relation between the two is not obvious. Among the probable practical implications, Kozyrev predicted diagnostics of troubles in complex systems. There are a number of scientific groups working in this direction. As an example, Arushanov and Korotayev, two established professors, applied the ideas of causal mechanics to the field of weather forecast. They showed results in getting more precise and earlier prognosis. No doubts that methods of detecting causes are of crucial importance for medical diagnostics. There are some practical achievements on that way too, and time waiver is the most important pioneering step developing Kozyrev's ideas in that direction. Finally, existence of time flow as a natural substance opens the door for the invention of new means of communication, instant communication. Due to the omnipresence of time and its ability to appear simultaneously all across the universe, this kind of communication promises to be universal. This outcome of the theory became a focus of Kozyrev's research at the fourth stage of the projects. So from 6 consequences of the third stage, now we go to the first scheme with the 4 stages of Kozyrev's projects. In the period from 1977 to 1979, Kozyrev and his reliable and long-term assistant Nasonov, who was also a marvelous figure. He was vice director of a big plant, so he was occupied heavily with the work during all his daytime, and almost all days after his work, he came to Kozyrev, to Observatory Pulkovo, and worked for 4-5 hours with my father, absolutely free for charge, for many years. So they discovered a new method of astronomical observation based on the properties of time. They did it on the same Crimean telescope, which had allowed Kozyrev to register lunar volcanic activity 20 years before. The night sky was scanned near big stars and constellations with the light-shielded reflecting telescope. It was found that the properties of electric resistors used as detectors regularly changed when the telescope was directed toward the visible location of a star, which is strange for itself because, again, the light flow was blocked. Almost the same change was detected when the telescope was directed to the so-called true location, that is the place of on the sky where the star is invisibly present now, and also to its location in the future, symmetrical to the visible location in the past. These results were interpreted in the consequent article as an astronomical evidence for the reality of four-dimensional Minkowski geometry, because this geometry allows three conditions for the communication through time: when the communication is instant, or when objects move with the speed of light. The outcomes of the fourth stage were subjected to the most intensive criticism, not only by Kozyrev's opponents, but by a part of his associates also. Nevertheless, paradoxically, it is this claim about the existence of the instant, even advanced forms of communication that have been supported recently, they was supported recently by a number of proofs. Some of them may be found at our institute and our laboratory for the collection and analysis of empirical data. In the last part of my presentation, I will give a brief review of current situation with the theory of active time, indicating main directions of its development. The full version of this review can be found again on the same website in my article, which is called The Dotted Future of Physics of Time, unfortunately published only in Russian. Another most valuable source of information about current developments can be found in several very important and valuable articles by Lavrentiy Shikhobalov. There are three main ways, in my view, that lies in front of this new branch of physics. I used the image in my article, a night at the crossroad, embedded in Russian folklore, to depict the dramatic importance of the choice and to define specific risks connected with each option of the further development. Go right and you lose your life. Go left and you lose your horse. Go forward and you are alive, but forget who you are. This is one version of the legend, what is written on this stone. Regarding our case, I associate the way on the right with the further proof or disproof of causal mechanics. This is the way parallel to the second stage of Kozyrev's project. It leads into the domain of astronomy and kinematics. I call this perspective relativistic because the intrusion of the principle of causality into mechanics, as offered by Kozyrev, will affect considerably our cosmological views in a way similar to Copernicus or Einstein ideas. Causal mechanics is not in contradiction with both Galilean and Lorentz relativism, as it is not in contradiction with Newton. Moreover, Kozyrev himself tried to conjugate his mechanics with Einstein-Minkowski time-space formalization. But it obviously promotes utterly different interpretation of the non-relativistic phenomena, shifting priorities from geometric to chronometric version. These two versions are equivalent both in Newton mechanics and in relativism of early Einstein and Poincaré. The fact that in the later version of relativism developed by Einstein on the basis of Minkowski spacetime, the first, that means the geometrical version gained a priority over the chronometric one. But it is not due to ontological reasons, but to the capacities of human mind and imagination. Geometrical descriptions are much more easier to operate, to work with. Everybody knows how it is difficult for us to deal with different calendars, even very simple arithmetical tasks. Causal mechanics establishes an ambiguous ontological priority of time over space. Time is the cosmological agent, while space, in Kozyrev words, is only a passive arena of events. Consequently, it is only natural to associate the detected changes of physical conditions in the universe with the changes in the quality of time, not of space, as it is practiced today. Doppler effect and Hubble law, that is the empirical basis of the Big Bang theory, could be more logically explained, in this case, not by the expansion of space and by consequent recession of galaxies, but by the contraction of time. One comprehensive mathematical formalization explaining gravitation, the Hubble law, phenomena of dark matter, and relict radiation as effects of the heterogeneity of time has been presented already to Russian audience by Evgeny Polyakov, and his Russian article is also presented at the website of the Institute of Time Exploration. This trend of development was strongly stimulated during last decades through the growing dissatisfaction with Einstein relativity. New empirical data on the speed of light in coaxes, together with more accurate measurement of Doppler effect by cosmic NASA laboratories equipped with GPS clocks, challenges this theory. American researcher Tom van Flandern published in 1998 an article entitled "What Global Positioning System Tells Us About Relativity?" Tackling the problem of competition between Einstein and Lorentz versions, he notes cautiously, "Certainly, experts do not yet agree on its resolution, but of those who have compared both LR is Lorentz relativity, with SR, special relativity, to the experiments, most seem convinced that LR more easily explains the behavior of nature. And it is worth to remind that Lorentz relativism supposes the existence of ether and absolute time." Another push came from the reconsideration of results of Michelson and Morley experiment, the only empirical basement of Einstein. Our laboratory presents a number of challenging articles on that topic, published in Progress in Physics and some other periodicals by Reginald Kehel since 2003. You see here only two of his presentations. There is a lot of them. Kehel states that despite the widely known opinion that the experiment conducted in 1887 proved inexistence of ether, in fact, actually, it proved its existence. This conclusion is based on the accurate analysis of raw data and is supported by newly appeared results obtained with the Michelson interferometer in different media. It is very important that it was used in different media, in vacuum, in different types of gas, which is what Michelson and Morley didn't do. Simultaneously, the same stuff was published by a Russian researcher, Professor Valery Demyanov. You see his name on the bottom. You see also that there are, Kehel is not the only person who writes about this problem. There is a huge amount of articles in the Cornell University Library, and Demyanov is presented there. And what is interesting, Demyanov claims, although you see his article appeared only in 2009 and the first article appeared in 2004, he claims that he made this discovery of the mistake in the interpretation of Michelson and Morley experiment in the 1960s. I asked his friends why he was silent for 40 years. And they said just because he is a military officer and he was, there was secrecy, which is now over. Among the most important links between Kozyrev ideas and this movement for rehabilitation of ether are the works of Professor Igor Rakityansky from Kiev Institute of Geophysics. A proponent of ether and absolute movement, he proposes to consider the constant of causal mechanics or the course of time, as the velocity of absolute movement of Earth, produced by the superposition of cosmological rotations. Rakitiansky refers to the measurement of causal forces distribution over the Earth, which was conducted by Kozyrev in 1959, and offers their recalculation with improved formula. He offers also a thorough analysis of the main independent evidence of mechanical asymmetry obtained by Japanese researcher Hayasaka and Takeuchi in the end of 80s. They found anomalous weight reduction on a rotating gyroscope very similar to effects described by Kozyrev. In the late 90s, Hayasaka led a new series of experiments independently already because their works were criticized, and Takeuchi agreed with the criticism, but Hayasaka didn't accept explanations and continued with these experiments. It was a very similar story to the Michelson-Marly, because maybe you know that there was a third figure there, Miller. And Miller didn't agree with the interpretation of the zero effect. And he continued to work. So there is also huge material from Miller experiments which also contradict the relativity, the special relativity of Einstein. They found, Hayasaka led a new series of experiments, not with the weighing on the scales rotating gyroscopes, but measuring the speed of their free fall. And he also found a basic mechanical asymmetry. So right rotating gyroscopes fall with the different speed. Of course, it is in the boxes, so all effects of air are neglected here. So the additional forces of time detected by Kozyrev 60 years ago are considered today by some theorists as the manifestation of absolute movement of our solar system of space. Of course, it is the incompatible interpretation with Kozyrev's idea. Which one of the two ideas is true? It seems that the answer should be found in the further experiments and observation. If the observed anomalies will show regular interconnection with seasons, it will be an argument in favor of Rakitiansky idea, the idea of the absolute movement. But there could appear new arguments in favor of original Kozyrev idea as well. For instance, if the position of left-rotating and right-rotating planets in their orbits will fit the predictions of causal mechanics. I agree completely with the Moscow physicist Alexander Parkhomov, a virtuoso experimenter, who has replicated in many ways Kozyrev experiments and kept for a long time very skeptical view on their quality. He wrote in one of his English articles, "Thus, at present, there are no experiments or astronomical observations which could unambiguously validate or disprove causal mechanics. The undoubted outstanding importance of Kozyrev's theory, its potential cosmological and ontological significance, makes this situation intolerable. The reproach is addressed to physicists. It is high time to pass from speculative reasoning on causal mechanics to its comprehensive and virtually qualified verification." Like our imagined night, causal mechanics may obviously gain or lose its life on that way. But its failure would not mean the discredit of the first stage of Kozyrev projects. The first stage, questioning the omnipotence of the second law of thermodynamics. I associate the development of this idea with the way forward on our scheme and call this perspective synergetic. If we define synergetics in the Hawkins terms as an interdisciplinary science focused on the phenomena of self-organization, Kozyrev project explicitly falls into this definition. Indeed, in a way, he is much more radical than Prigozhin in dethroning the power of entropy. While in Prigozhin's synergetics, equilibrium state ceases to be the only natural or climax state of physical systems, in Kozyrev's theory, the active time, theory of active time, it becomes simply impossible. If the flow of time exists independent of our perception as a physical reality, then equilibrium state is an abstraction, non-existent in our world. That is the quotation from Kozyrev. While Prigozhin ascribes some limited creative function to chaos, Kozyrev ascribes inexhaustible creative potential to time, bringing negentropy into this world and compensating the destructive work of chaos. I will not say much about this perspective of development because it's really vast, and some of its imaginable targets were already indicated. Apparently, among the three, this is the way to become rich, because it is about getting new and inexhaustible source of energy. But just because its direction is stimulated more than to others with the hope of getting practical profit, there is also a serious danger for a scientist to forget what he is on, what he is in this way, as predicted by legend, and to become a moneymaker. I will just mention several groups and individuals among Russian scientists who studied anomalies in periodical physical and chemical processes, similar to what Kozyrev has studied during the third and the fourth stage of his project. First, Professor Simon Schnoll, with his colleagues, studied for many years in Moscow State University regularities in fluctuations of different physical-chemical processes. They registered discrete manner of fluctuation. That was one very important finding, and also its dependence on astronomic periodicity. In one of their articles, they proposed the existence of cosmological factor responsible for the irregularities and fluctuations, and guess that this factor might be the change of the time unit. Professor Sergei Karataev and his colleagues also have been conducting long-term experiments in two Moscow laboratories since 1993 till 2004, so 10 years long experiments. They studied macroscopic non-local correlations between dissipative probe processes like variation of electrode charges or fluctuations of electric current in a photomultiplier on one side, and large-scale natural random processes on the other, like solar activity, meteorological or geomagnetic activity. In the set of their overlays of the periodical data for 10 years, they reliably detected what they called advanced correlations. To put it simply, the changes of fluctuation in detected probe processes started earlier than the natural processes related to them and regarded as their cause. In the article with the challenging title, Random Future as Existing Reality, they wrote, it is an article by Korotayev, Morozov, and Serdyuk. They wrote, "We have described the development of the outlawed idea of Kozyrev, that of feasibility of observing future as existing reality. We keep admiring this idea because it is proved experimentally up to its practical application to prognostics." The Kiev Observatory leading specialist Alexander Pugach has been conducting non-stop registration with Kozyrev torsion balances of mini size since 2007. The first fabulous result was achieved on November 23, 2007, when he observed the reaction of 4 devices to a sun eclipse. It was not visible in Kiev, this sun eclipse. But as he put it himself, he couldn't believe his eyes. Just after the maximum phase of eclipse, the pointers of the balances were animated and started to move in a complicated manner with the overall amplitude of 200 degrees. Since that time, Pugach starts systematic records of the torsion balance, daily motion. These observations showed balance to follow the regular pattern with the period of exactly 24 hours. This pattern appeared to be essentially different from that of daily temperature course, because, and that's why this rotation could not be explained as a thermal change, a result of thermal fluctuations. Pugach assumed that the rotation of the balance may be caused by some unknown properties of solar radiation. This assumption was significantly reinforced during the observation in 2010, as you see here. Remarkably, the maximum shift of the balance was registered 1 hour before the actual eclipse, again the advanced reaction. But even more inspiring for the researcher were the results of the most recent observation of Venus and Moon conjunction taking place in 2010. Balances located in two different buildings with 150 meters between them showed correlated reaction to the event. It is a very tiny event, Venus conjunct lunar. The reaction was not connected with the course of temperature and started some 8 hours before the conjunction. Trying to explain this unbelievable reaction, Pugaч assumes that it may be conditioned by the variation of the parameter called by Kozyrev the density of the time flow. Already mentioned, Alexander Parkhomov is widely known due to his works on the variability in the rates of radioactive decay, the patterns of white nose, flicker nose, but later he made a series of provoking experiments studying behavior of his detectors in some specific environments. For instance, in houses and flats inhabited by poltergeist. When interpreting time lags he observed in one of his anomalous zones, he wrote, Nicolai Kozyrev claimed that the course of time may differ in different systems. I read Kozyrev works in former times, but I didn't understand him well, and thus was suspicious about his claims. I tried to replicate some of his experiments, and I have even observed similar effects, but I always managed to find alternative explanations, not requiring introduction of the new substances. But what if Kozyrev is right, and the striking abnormalities in the properties of objects that have been subjected to psychokinetic manipulations or have been in anomalous zones are the result of the infringement of time course, usual for other objects? Developing this idea, Parkhomov makes an assumption that the Noether theorem, conjugating energy conservation law with evenness of time, reflects physical reality and leads us to turn from the notion of the conservation of energy to the notion of conservation of energy and time, or even energy time. But most inspiring in Parkhomov's view is the empirical fact that the reduction of variation in the the distribution of radioactive decay may be influenced by technical devices. This extraordinary effect was registered by him with the Karavykin generator of torsion field and demonstrated with this graph, with these red lines. This is the very, from Parkhomov's view, unbelievable behavior. While an increase of variation might be well explained by interfering factors, the decrease is really strange. For this ordering of a random process means the possibility to correlate independent physical events, and hence to regulate what is usually conceived as accident or spontaneous. Parkhomov takes this result as a direct empirical confirmation of the fundamental Kozyrev postulate, according to which the rigidity of cause and effect relation is one of the physical characteristics of our world. Is the referent, natural referent of this material characteristic material or non-material? The negative answer to this question corresponds to the third way of our crossroad, and I call it creativistic. Its central idea is the identification of time with the universal creative force, that is the development of basic cosmological assumption lying behind Kozyrev project. Time in this framework is regarded not as natura naturata, but as natura naturans. As a consequence, this approach demands most radical change of method. Using Wilhelm Dilthey vocabulary, if time is not a creature, but an agent of creation, the science studying it may not be considered a Naturwissenschaft, but should become a Geistwissenschaft. So objectivism innate for the former should be seized, and participating strategy of cognition should be employed instead. The most consistent proponent of this view is the closest Kozyrev's disciple and assistant during his last years, Mikhail Vorotkov. Like Parkhomov, Vorotkov is a talented and highly skilled experimenter. And like Parkhomov, he was critical about the way Kozyrev conducted his experiments. This flippant manner of changing different schemes and conditions of experiments, detectors, and probe processes annoyed Vorotkov and raised skepticism about the quality of these experiments. Vorotkov wanted one but perfect and convincing experiment. By the way, it is what Solzhenitsyn also demanded from Kozyrev, or recommended in his letters. Kozyrev's denial to concentrate on this task led Vorotkov to a growing dissatisfaction that later, after Kozyrev's death, burst in severe personal crisis. Creativist approach was outcome of this crisis. In my article, I tried to represent systematically main principles declared by Vorotkov, and here I reproduce briefly these main principles, and it will be the end of my presentation. Vorotkov himself positively evaluated my representation of his ideas. First principle of randomness. Time does not carry with it energy or impulse, but it mediates and regulates cause and effect relations. Active time comes into play wherever instability occurs and the random processes take place. In order to operate, time needs bifurcation. In technical terms, it means that attempts to get rid of noises, fluctuations, and other forms of instrumental instability is in fact a way of eliminating the very mechanism for which time can be approached. So the worse is the measuring system, the better are results. Second principle of non-locality. The system should be open. Ordinary experimental strategy strives for better isolation of measuring system. In this case of studying time, Vorotkov compares this strategy with the idea of cutting off trees in order to study the noise of the wood. Creative force has nothing to do with the closed system, he claims. And here he is congenial to Prigozhin, who used to say that unstable systems can be called sighted, because they acquire a quality of higher sensibility toward their distant attractors. Third, closely connected is the principle of interaction. All experiments with time should take a form of a dialogue. If the object of study is not a dead matter, but a creative entity, for instance, a man, and if you ask him many times the same question, he finally stops answering you. Here, in this point, Vorotkov found for himself reconciliation with the experimental strategy of his teacher. He understood why Kozyrev so strangely, by consistently ignored the issue of high repeatability of results. He just knew the specific quality of his object. Nature loves to hide, said Heraclitus. Time sees to love it even stronger. And finally, there is a principle of selectiveness. Time influences only those detectors which are connected with the object of observation by cause and effect relations. It means that in active system situated near a detector may have no influence on it, but the similar and much more distant system will influence it if they had some interaction before. This principle explains how Kozyrev's method of observing stars in their present location works. It is a promising principle, for it gives hope to get a tool of navigation in the boundless stream of time. But on the other hand, it is also distressing, because it implies the multiplicity of time manifestations. Vorotkov compares Kozyrev's time with Proteus, permanently changing its appearance. And so the question arises if the pursuit of time is a way of methodological suicide for natural science. The way on the left in the legend was charged with the loss of the horse. This horse, in our analogy, may be a scientific method. Indeed, the overall picture of Vorotkov epistemology gives a strong feeling that experiments conducted in this way would look much more like mantic practices, such as ancient haruspici. Obvious are the dangers waiting for us on this way. But what if ancient thinkers were wise in this respect no less than in their philosophy? What if this tradition of asking nature about future was the primitive and God knows how obtained method of interaction with time, much more efficient than our statistical strategy? One of the most famous representatives of Russian cosmism and Russian philosophers, Nicolai Kozyrev, wrote in his book Philosophy of the Free Spirit, physical causality discovered by the natural science doesn't acquaint us with the inner interconnection of things. The creative energy of the inner life of the world remains undisclosed. When this inner force of nature will be discovered and recognized as an expression of the inner creative energy, then it will cease to be material in physical sense. It will be inserted into the life of spirit. And I believe Nicolai Kozyrev made a decisive step on that way. Thank you.